Hello everyone, welcome back to another video. This is Pranav, and in this video we'll be talking about the topic expert systems. So expert systems are come under the domain of AI, wherein these are used to basically make intelligent decisions, or these are designed to solve real world problems in a particular domain that normally would require a human expert, and it can solve many types of problems too. So developing an expert system involves extracting relevant knowledge from human experts in the area of the problem, and these are called domain experts. So coming to components of expert system, these have knowledge acquisition facilities, a knowledge base, and we have a knowledge based management system, an inference engine, a workspace, explanation facility, reasoning capability, and an UI. So characteristics of an expert system are that it is capable of handling challenging decision problems and delivering solutions. So these use knowledge rather than data for a solution. That is, these have much of a heuristic based knowledge approach than an algorithmic approach. And expert systems have the capability to explain how the decision was made. And these can also explain the reasoning on suggested decisions, display intelligent behavior, draw conclusions from complex relationships, and also provide portable knowledge. So in an expert system shell, a collection of software packages and tools are used to develop expert systems. And the limitations of expert systems are, these are not widely used or tested yet, and they are limited to relatively narrow problems, cannot readily deal with mixed knowledge, the possibility of error is pretty high, and cannot refine own knowledge base, and it is also pretty difficult to maintain and have a and might have a higher development cost initially, and these also raise legal and ethical concerns too. But the capabilities of expert systems are not yet explored completely. So few of these are strategic goal settings, that is our flow, wherein we explore the impact of strategic goals, and then we have planning where we have impact of plans on resources that are required to train these. And come to the design part, these integrate general design principles and manufacturing limitations. Decision making is where we have provision on advising on decisions, that is from domain experts or any kind of rule inferences. So quality control and monitoring, where we control the quality and assist in finding solutions, and also the final part, that is diagnosis, that is looking for causes and suggest solutions. So components of expert systems are basically fuzzy logic. So a specialty research area in computer science, wherein we have multiple domains of having knowledge, having decision making capability. So these are simply not limited to true or false decisions. These also have a certain degree of having the truth inference or false inference, where we can implement this logic to have solutions or decision making capabilities. Also in backward chaining, that is a method of reasoning that starts with conclusions and works backwards to the supporting facts. And forward chaining is the same similar way, wherein we have a method of reasoning that starts with the facts and works towards the conclusions. So here we see the diagrammatic representation of an expert system, wherein we have experts that train the knowledge base or add to the knowledge base, and the knowledge base acquisition facility basically inferences from the experts, the from and from the UI, that is through feedback, that is once the user uses, if he has anything to give as an input, so that is also taken as a knowledge base acquisition. And we also have explanation facility and an inference engine to train the knowledge base too. So all this is stored in the knowledge base and inference into the user interface for further implication. So let us just see an application wherein we have a mortgage application for a loan, that is for 100,000 rupees, and 100,000 to 200,000 rupees. So that's 1 lakh to 2 lakh. And if there are no previous credit problems, and if the monthly net income is greater than 4 times monthly loan payment, and if down payment is 15% of the total value of property. So if net income of borrower is greater than 25,000, and if employment is greater than 3 years at the same company, then these are the inferences that are made in a rule based decision making system. That is, the expert system makes these decisions in a flow to make, that is to accept the applications or else check for other credit rules, and reject the application. So explanation facility is a part of expert system that allows a user or decision maker to understand how expert system arrived at certain conclusions or results. That is to how that is to explain rationally how the decision was made. And the knowledge acquisition facility is where it provides a convenient and efficient means of capturing and storing all the components of the knowledge base. So this basically has an expert who interacts with the knowledge acquisition facility, and it is appended or updated in the knowledge base based on previous and future inferences. So expert systems development. So these uh, have basically few steps, that is determining the requirements, and then we identify the experts, that is to the particular domain that we tend to solve a problem towards, and also construct expert system components that it is the domain components that are required to actually train the complete system and have an efficient user base, and also implementing results and maintaining and reviewing system. So the area of knowledge is the domain for the expert system. So this is limited to that particular field. And coming to participants in the expert systems and its developments. So domain expert is someone that is who has a particular experience in this particular field, and the individual or group whose expertise and knowledge is captured for use in an expert system. So basically the domain experts have inputs towards the acquisition systems which are updated into the knowledge base. So a knowledge user is someone who uses and benefits from the expert system, that is the user end. And a knowledge engineer is someone who is experienced to train or design the program in such a way to and also to maintain the expert system in such a way that it provides the accurate results. So this is the diagrammatic representation of the previous slide. So evolution of expert systems can be seen in this way, wherein we have before 1980 we had traditional programming languages, and in 1980s we had special and fourth gen languages, and in the modern era we have expert system shells, wherein it has multiple inference rules and engines to make sequential decisions, that is to yes or no, and also implement further implementations such as involving AI or machine learning algorithms to have a better throughput for the expert system. So coming to the limitations part, it is not widely used or tested, and it is limited to relatively a narrow set of problems, and these cannot deal with mixed knowledge kind of scenarios wherein you have multiple domains, and these might not be the accurate use case scenario, and also the possibility of error is pretty high. And these cannot refine their own knowledge base, since it's not an algorithmic approach. It is just the knowledge base that is being updated by the maintenance or engineers that are or the users that use it. So it is actually pretty tough to maintain and have and might have a high development cost. So due to all these reasons, these also raise legal and ethical concerns too. So, when can we develop an expert system? So, the problem cannot be specified in terms of well-defined algorithms. So, the problem requires consistency and standardization. So, in this domain, the problem area is narrow or limited, and when the task is hazardous, that is, if it might need a lot of man force, and it might need a lot of automation that is need to be done. So expert systems can be deployed in this particular area. So there is a scarcity of experts in the area, and also the problem involves complex logic or large number of rules. So in this case, expert systems can be implemented with the inference rules. So human experts have successfully solved similar problems too, and advantages of expert system are it enhances the decision quality, and it reduces the cost of consulting experts for problem solving. It provides quick and efficient solutions to problems in narrow area of specialization. It offers high reliability of expert suggestions or decisions, and it gathers scarce expertise and uses it efficiently. So the continued examples are: it can tackle very complex problems that are difficult for human experts to solve. It can work on standard computer hardware, and it can also not only give solutions but also the decision logic and how the solution was arrived at. So limitations, as we just saw, are knowledge base might not be complete, and since each problem is different, the solution from a human expert may be different too. That's in different perspective, and it is pretty expensive. Takes a long time to build and develop these, and since it is taking a long time. It is also not so cost effective. So large expert system is difficult to build and maintain. So thank you guys for watching the video. Hope you guys liked it. Please leave a like.